All right, and then we looked at the number 8 vial. So this one had been closed. We did allow it to outgas a little bit, otherwise the pressure that was going to be built up would be too great. It can cause a potential, explosive environment, not, terribly damaging, but we don't want anything to burst. How do we know gas built up? Because we're looking at the gas that is still filled up in the green balloon, and as well as in the purple and in the red. So anyways, we just outgassed a little bit over the course of this 24-hour period, but look what we did. Where might the alcohol be found? So in this vial, you have a couple different layers. You have this darker, rich red layer, which is sitting on top, this pinkish, purplish, I'm gonna call it almost like a pinklish or something, I don't know, kind of color, but that is where the fermentation product is going on, in this purplish, pinkish liquid. We're gonna call that the liqueur. If we were to analyze what the saliva test alcohol detection would give, this is just the test strip for saliva, you can see that if I just use a 2-fold dilution of that top layer of the reddish material, we don't really have any kind of detecting of any kind of alcohol. Whereas if we use the same 2-fold dilution, but this time I'm gonna go down deep into that liqueur, we actually see that we have some alcohol detection, and it's at least 20 milligram per 100 mil. And this is, again, using the saliva test. We use the breast milk alcohol test because it's a little bit more sensitive, but in this particular case, just wanted to use the saliva just to be able to see if we can see those differences. And you can see how the liqueur definitely looks different than that top solution. Again, both of these were diluted 2-fold, 1 mil liquid and 1 mil water. But the fermented product, i.e. that purplish pinkish liqueur in this vial, is driving that alcohol fermentation from the yeast.